Okay, let's continue topic 2. So graphical techniques to describe a set of quantitative data, right? Quantitative data. Now we have this numerical data, right? And we will first look at the example first for the quantitative data. So there is a game called Bridge. Bridge is a kind of a card game, right? Like a poker or blackjack. It's a card game, and Bridge is played by a lot of people all over the world. And the popular version of Bridge is Duplicate Bridge. You can just check what Duplicate Bridge is. What actually I don't know what Duplicate Bridge is, but it's played lot in the U.S. and then there's clubs and tournaments all around the world, and those league, what the league called American Contract Bridge League, is a kind of an organization like a professional. Not, it's not professional league. It's amateur league, but it's a American. It's a popular organization that runs Duplicate Bridge, and anyone who has played in these club games will notice that in this bridge game, if you play this bridge game, then you will notice that the majority of people that who play this bridge are basically seniors, old people, right? Now, usually, if you look at some American Hollywood movie, then there are sometimes you will see the card game, old people playing like card games, like some or bingo games or those kind of things. So seniors play those card games. To gain useful information about this age, uh, basically those ages are basically between 16 and 99. Okay, then we want to know how these ages are distributed, and how many old people are there, how many young people are there. Okay, and whether the ages of the bridge players are similar, such as similar, everybody is like in their 60s, or there are some people who are very young and some people are very old and they are very equally distributed. So we want to know this kind of information. So actually, first thing for this quantitative data is also we want to make some frequency distribution. And then from this frequency distribution, we can draw a histogram. And actually, this histogram is very similar to bar chart. Actually, a histogram is a special case of a bar chart, right? So we will make a frequency distribution, frequency table, and then we will make a histogram. But in order to draw this frequency distribution, or in order to make this frequency table, we have to make classes. We have to assign classes. Class is what? We have to basically separate them into different groups because their age is 16 to 99. So we will separate them into 10 or 9 groups. First group is whether they are they are teenagers, and 20s, 30s, 40s, 50s, and so on. So ages that are more than 10 and less than or equal to 20, then it's the first group. Ages that are more than 20 and less than or equal to 30, then it's the second group, and so on until 90 to 100, right? And then we count those numbers. So 10 to 20, and 20 to 30, 30 to 40, and so on. And then we count number of people in this age group. So 27. So 27 people are in their 20s, and then there are a bunch of people, like 40 people are their 50s, 36 people are in their 60s. Okay, and each class represents basically ages that are more than this 10 and less than or equal to those 20. Okay. And then we can draw histogram. So histogram, basically we have this 20, so 10 to 20, right? 10 to 20, 20 to 30, 30 to 40, and so on, 90 to 100. And there are 6 people are teenagers, 27 people are in their 20s, 30 people are in their 30s, 16 people are in their 40s, and so on, right? And the histogram. And what's the difference between the bar chart and the histogram? These numbers are ordered, right? This x-axis, the horizontal axis, right, basically matters. You cannot change the order. You cannot change this order. If you put this 36 first and then 40 later, then basically you're losing information. Okay, you're losing information. In the bar chart, previously in the bar chart, for example here, like you can change the order of these guys, GNM, Post, Star, and Sun. If you change the order of these guys equally, change the order, then still you are not losing any information. But here, in this histogram, if you change the order of these groups, right, these classes, basically you will lose information. Because 10 is definitely younger than 20, 20 is definitely younger than 30, and this number actually matters, and you want to see how people are distributed based on the age, whether they get older, then how the distribution how the frequency will be different. So that is what we can see from this histogram, right? So that is important discrepancy between histogram and the bar chart. Okay, and histogram have similar interesting features. First interesting shape of the histogram that we may be interested in, we may need to remember is symmetry. Some histograms are symmetric. Okay, symmetric is what? In Korean, 대칭, right? 대칭. Right, 대칭. So if we draw a vertical line down the center of the histogram, right, like this, right, like this, we draw a vertical line, and then this left part and this right part are basically the same. Then that's a symmetric. Symmetric does not have to be like this shape. This is also symmetric, right? Symmetric. The left part and the right part are the same. Also, this graph, the left part and the right part are the same. Also, like you can draw like this, and the middle is here. Then this is also symmetric, right? So symmetric means left part and right part are basically the same. And another interesting shape of the histogram is modality, right? Modality is what? Mode. We will learn mode in the chapter topic 3. Mode is the value that occurs the most often. Well, you can think about this as a 봉우리. Mode does not mean in Korean 봉우리, but 봉우리 means what? Peak, right? Peak. Whether there is a one peak or two peak, where is the peak is basically modality, right? So first thing is the unimodal histogram has a one peak, single peak, right? And bimodal histogram has two peak. Trimodal histogram has three peak, right? So three peaks. So bimodal, there is one peak here, and then there is another peak here. This peak does not necessarily have to be higher or same height as this one, but still this is a two peak. But unimodal one has a one peak, right? Trimodal one like this, then there's a trimodal like this, trimodal histogram, right? So there is a modality, so unimodal and bimodal. Among those professors in our department, we kind of after the midterm or after the final, we always talk about this. Our score grade distribution is bimodal. There are bunch of students, not bunch, but there are a few students who's doing not good, then like this, and then there is a bunch of students who is doing well. So there are two separate groups, and then we can call this is basically bimodal distribution. Hopefully in our class we don't have a bimodal distribution. Hopefully we have unimodal distribution like this, right? That will be the best distribution that I want you guys to be distributed, right? Skewness. So skewness is whether the tail of the distribution is long in the right side or left side. So this is a positively skewed. Then the right tail is long and left tail is short. And negatively skewed, left tail is long and the right tail is short, right? Then it's negatively skewed and positively skewed. And this is a skewness, another interesting shape of histogram. And the last thing is a bell shape. Bell shape means histogram is symmetric, 대칭, and unimodal, only one peak, right? So that is symmetric histogram. Okay, many interesting statistical distributions are actually bell-shaped, unimodal and symmetric. And our techniques, that those like statistical techniques that we are going to use in this course, is based on the fact that many distributions are bell-shaped. Okay, so bell shape is actually a very interesting feature of the statistical distributions. Okay, so from this table, right, the frequency table that we write down, we can also write down the relative frequency table, right? Relative frequency table. So we will see this relative frequency table a little bit later on a slide. So here, okay, so there are relative frequency table, okay. So there are 200 students, 200 bridge players, and 6 people are in their teenagers, right? They are teenagers, so 3%. 27 people are in 20s, so there are 13.5. Actually, this rounded up, so 13.5%, and 30 people are in their 30s, and so on. So that is basically relative frequencies. Okay, relative frequencies are here. So this is a way to describe quantitative data. But there is actually another types of quantitative data, which is time series data. Previously, we classify the data into three different types. One is qualitative data, right? Qual, and the other one is quantitative data, and then ordinal data, right? Now we have this quantitative data. There are 3 different types of data. Actually, we don't have to maybe write down this quantitative data has 3 types. Actually, there are 3 different types of different ways of classifying the data. And then this classification have another three different types. First type is a cross-sectional data. Cross-sectional data is what? Observations are measured at the same point in time. Observations are measured at the same point of time. So for example, you can think about stock market data, like 주식시장 data. And stock market, there are Kospi 200 firms, right? So basically 200 companies, right? And there are today's, stock price, right? Today's stock price at the end of the market, right? End of today's stock price, end of today's stock price. Then there are 200 firms, and each firm there is only one number, right? Stock price, like Samsung Electronics has like 5만 원, like 50,000 won, and so on. Like those kind of case is cross-sectional. Okay, and there are time series data. Time series data is only one firm. You choose one firm, like Samsung Electronics, and then there it's actually stock price for 100 days, right? 100 days daily stock price. Then that's a time series data. Only you follow one guy, right? With many different, times. Then there's a time series. Okay, time series. Cross-section is what? Many guys, but only one time, right? Only one time. One time slot, right? Snapshot. And then there is what we call panel data. Okay, panel data is not here in this slide, but panel data is what? Many cross-section. So these 200 firms are basically cross-sections. So 200 firms, and they're 100 days. It doesn't have to be like 100, but 100 days daily stock price. Then that is a panel data. So many firms and many time, right? Then that's the panel data. And for time series data, we can draw a graph that is called a line chart. So line chart will show you how the stock price of Samsung Electronics change over time, right? So this is a example of a line chart. So gasoline price, retail gasoline price, average retail gasoline price is a variable, right? And from monthly average retail price of gasoline, this is basically the variable, right? Variable. Time series variable. from 1976 to current. Then this is first month, 25th month, 49th month. So every month there is a data point, right? The number of the price, the price, right? The price is drawn as a graph, and that is basically the line chart. So time series data. If you have time series data, you draw the line chart to describe the data. Okay. So, and then in the previously for qualitative data, we described the relationship between two qualitative data variables, right? Now we can do also the same thing for two quantitative variables. So we have two quantitative variables, and for example, like one's height and one's weight, right? Those two, 신장 and 체중, two quantitative variables. Then we can draw we can check the relationship based on drawing some graph or tables, right? We can describe their relationships. So in order to do so, for two quantitative variables, what we can do is a scatter diagram. We draw a scatter plot or scatter diagram. And we put independent variable as x and dependent variable as y. Okay, so y will be the in the vertical axis, x will be the on the horizontal axis, and we will call x as an independent variable and y as a dependent variable, and we will draw a scatter diagram. An example is here. A real estate agent wanted to know what's the relationship between the selling price of house and its size, is basically area size. Okay. To acquire this information, he took a sample of 12 homes, right? 12 homes that had recently sold, and recording the price, house price in thousands of dollars, and the size, house size in hundreds of square feet. So this is a size and this is price. An important thing here is there are two variables, right? The two variables, variable 1 and variable 2. Variable 2, two variables. And then there is a 2,354 square feet and $315,000, and this is from the same house 1, and this information is from house 1, and this information is from house 2, right? So you should not mix these numbers, right? You should not mix these numbers. It doesn't have to be like this. Okay, it doesn't have to be like this. You should not mix these numbers. And 2054 and 315 belongs to house 1, 1807 and 229 belongs to house 2, and so on, right? There are 12 houses here, okay? 12 houses. And we draw scatter diagram or scatter plot of here. Okay, $315,000 maybe around here, right? And then 2,354 maybe here, and then this guy, maybe this guy is house 1, right? House 1, and so on. You basically pick, check the point and draw this scatter diagram. Okay, and you can see there may be positive relationships. As house size goes up, house price may go up, right? Then this is a positive linear relationships. Okay, so there are interesting patterns that we can tell from this scatter diagram. First thing is a linearity, and the second thing is the direction. So positive linear relationship, negative linear relationship, or weak or non-linear relationship, U-shape or V-shape non-linear relationships, right? Another example is oil price, crude oil price, like a Brent crude oil or WTI, West Texas Intermediate, crude oil price on the x-axis, crude oil, and gasoline price on the y-axis, right? Gasoline price on the y-axis, and you draw this scatter diagram, then you can definitely see this, positive linear relationship between these two. They are strongly related to each other. Okay, that's what we can see from this pattern of this scatter diagram. So important thing: positive linear relationship, negative linear relationship, and weak or non-linear relationships. Also, we can use some linear regression. You may have learned linear regression before, but linear regression is a way to tell the relationship between two quantitative variables, but we will learn it in almost the end of this class, okay, end of this course. So there are some summary. I don't want to emphasize this. You can just read this. Quantitative data, we can use a histogram, a scalar diagram, also a frequency table. Also, you can use this frequency. Oops, sorry, what happened to this? Frequency table, frequency distribution or frequency table here, or relative frequency table here, all can be used. So I don't want to emphasize this summary, but you can also use frequency table and relative frequency table for quantitative data. Scalar diagram here. You can also use cross classification table if you make a classes of this, quantitative variable. Then you can also use cross classification table for quantitative data. So all those methods you can choose based on the purpose of describing data to someone else that you want to present the feature of your data. Okay, that's pretty much everything that we want to cover in topic 2, and we will move on to topic 3 in the next time.